Hello everybody. Okay, let's get into the other part of section 8.2, which talks about rationalizing the denominator of a fraction. And some fractions that contain radicals, we sometimes do not want to have a radical left in the denominator in the first place. So the way we're going to get rid of it is we're going to do something called rationalizing the denominator. The denominator, our denominator like square root of 2, like in this fraction right here, is not a rational number. So when we say rationalize the denominator, we want to rewrite the expression so that we can, well, get rid of the radical in the denominator, have a rational number in that denominator, like a nice whole number, and then the multiplication that we're going to have to use is going to require some clever form of 1. So I'll show you in this first case. I have 5 over the square root of 2, and you ask yourself, well, what do I have to multiply by the square root of 2 to eliminate the radical? And the answer is the square root of 2. So we're going to rewrite this fraction by taking 5 and multiplying it by the square root of 2, and taking the denominator square root of 2 and multiplying it by the square root of 2. We know that the square root of 2 over square root of 2, work this out, square root of 2 times the square root of 2 is equivalent to saying square root of 2 quantities squared. And since squares undo radicals, we eliminate the radical in the denominator. So we're left with the expression 5 times the square root of 2 over 2. All right, how about this one over here? This one's a little bit more of a complicated denominator. We've got 5 times the square root of 3 down there, but that's nothing that we really want to deal with. So let's see how we could rewrite this one. Well, in this case, it's the square root of 3 that we need to focus on. I mean, 5 is fine, but we don't need to worry about that so much as the square root of 3. So what could we multiply? Well, that's right. We're just going to multiply everything by the square root of 3 again. So in this case, I'm going to take 5 over the 5 times the square root of 3 and multiply it by another square root of 3. So you see that I multiplied the square root of 3 over square root of 3 in both the numerator and denominator. And in this case, we end up with 9 times the square root of 3. And just like in the last case, when we take the square root of 3 times the square root of 3, we get 3. Now at this point, you could multiply this together in the denominator and you'll get 15. But note that 9 and 3 share a common factor. And that common factor is 3. So when we rewrite this expression, our expression will look like 3 times the square root of 3 divided by 5 when we reduce. So always reduce if you are in this situation where we've got a radical. All right, let's try it one more time. This time we've got 8 over the square root of 2a. And so we want to get rid of any radical. Now, it doesn't necessarily mean that we know what a is, or that a is going to come out to give us a radical number. We could end up with a rational number depending on what we substitute in. But when we say rationalize the denominator, we simply mean rewrite the expression so that we get rid of the radical altogether. So in this case, we're going to multiply the numerator and denominator equally by whatever the radical is, right? In this case, 2 square root of 2a. Square root of 2a. All right, so what's going to happen right here? We're going to end up with 8 times the square root of 2a in the numerator, and that's fine. Square root of 2a times square root of 2a in the denominator is going to give us just 2a. And is there any reduction that can take place here? Well, absolutely. The 8 and the 2 cancel, giving us 4. And so our reduced expression will look like 4 times the square root of 2a divided by a. There is no more reduction that can happen right here, so we're done. Okay, more in the next video.